This is your friend Mainak from Civil Center, and I welcome all of you back to our channel. So, friends, today we're going to discuss a very important topic, that is where we should place the lapping of our columns. So, we'll discuss that, and we'll also try to validate that using the Tekla Structural Designer software. So, without wasting any time, let's get started. So, first of all, I'll just show you briefly uh, interface and an idea about how the column lapping works. Suppose we have a beam here and another beam here, and I have a column here. So the column in between, we'll have this, and the height here, which we are having here, is this particular height is actually 3 meters. That is the floor to floor height. It is 3 meters. And then where should we lap the columns? So basically, where we should lap it is we should leave a space of L by 4 from this end and L by 4 from this end. So that means if we go by this L by 4, it will be L by 4 from here and L by 4 from here. So remaining this space, we can provide lapping in this region. So L by 4, if we go 3 by 4, it will be 0.75. So 0.75 meter from the top and 0.75 meter from the bottom. We can provide the lapping. So now we have, known about the lapping zone. Can provide the lapping in between. Now let's go to a little bit more detail. So suppose we are using 16 mm bars, 16 mm dia bars, which is our maximum bar dia size. And we are using a lap length of 50D. It will be given in the structural drawing. Whatever it will be given, we'll take that. So 50 into D. So it means 50 into 0.016. If you're calculating in meters, so it will be around 800 meters or 800 mm or 0.8 meters. So 0.8 meter space will be required for the lapping of the bars. So now let's see how we can stagger it. Here, the remaining portion, if we just take the remaining portion, if we just calculate the length of the remaining portion up to this portion, what will be the length? So it will be 3 minus 0.75 into 2. So it will be 1.5. So 1.5 meter space we have for the lapping. So now how can we arrange it? Let's see. So we are to give a lap and length of 0.8 meter. So suppose I have a, let me take a different color, and I have a bar here, which comes up to this much. It comes down from here. It comes up to this much. And we lap another bar from here. So suppose this particular portion in which we have lapped, this portion is your how much? 0.8 meter, 0.8 meter. It is taken 0.8 meter. So how much space is remaining? So we'll do 1.5 minus 0.8. It is 0.7 meter space which is remaining. So what we'll do, as 0.8 meter has already been occupied, the next portion, in this next portion, we'll just give another lapping, another bar. We'll just do like this. It will start up to this much. That is up to this much. And we can provide lapping from this zone. Exactly from this zone little bit, so that it becomes 0.8 meter and it is also staggered at the same moment. So like this we can arrange. So 1.5 meter we have overall for the lapping zone, and in this 1.5 meter we need to use and stagger the arrangement. So it is kind of staggered. So practically, as far as possible, we need to do this. Okay, some people say that we also need to keep certain space between the two lappings. That we can do if we have larger spans, 4 meter spans, then we can also give them some distance between the two laps. But here, as you can see, 100 meter is overlapping. So that also sometimes we need to do at the site. So we have discussed practically this example here. So now, having discussed that, let's now discuss why this is done, why this is essential using the help of the Tekla Structural Designer. So if you are new to this software, you can see my other videos on the Tekla Structural Designer playlist, and you can learn. So this is a model which has been designed, and fully loaded model which has been designed. We'll just go and see the results view, and in the results view, go to results and moment measure. You can just turn on the text of the forces here. The text will also be visible, but basically the thing is, they can just zoom in into any of the column and look, this is the moment which is acting on the column. So the purpose of the longitudinal bars are to resist the moments also. So here, as you can see at the center, as you can see, the load is minimum. The load becomes minimum at the center and maximum at the support, that is 1.51. So in this central region, the moment is the minimum. So when you are providing lapping to any bar, if you provide it in this region, then it is the safest. So that's why it is done. They tell to provide your lapping of the columns at the center. So this is the raw logic of this, and hope you found this video useful and also some insights of some things which you didn't know earlier. If you learned something from this video, hit the like button. It helps us to reach more people, and we hope that you keep learning and stay safe. Bye bye.